This is our last lesson for our exponent unit, and we're going to be writing exponential functions. Now, remember the last couple lessons we've been talking about exponential functions, which is just something of the form y equals a times b to the x. Now, think about what two things you need to be able to write one of these equations. You never need to plug in for like y and x to write the equation. You just need the other variables, so that would be a and b. And then if we remember back to a couple lessons ago what a and b stand for, a is the initial value, whatever you're starting with, and then b was the rate. It can be growth, it can be decay. So if you can pick out a and b, you can just plug those two values in and you've got your function. So essentially that's all we're trying to do today. Figure out a, figure out b, put it all together. Okay, let's do the reverse of what we learned last time. Last time I gave you a function and I had you graph it. This time I'm going to give you the graph and I want you to write the function. But again, you still just need a and b. If you remember from the shortcut, guys, the a value is the y-intercept. So on this one, and I apologize, these graphs are, now that I'm looking at it, like pretty terrible. You can't see the tick marks. We're going to do our best though. This copied so lightly. So this is 5. The y-intercept is 1 under it, so it's obviously just 4. Deepest apologies, this is hard to read. I promise on an exam or a quiz it would not look like this. I could come over here on this one, and there's the y-intercept up there at 15. So I have half of what I need. We usually write it in parentheses, remember? You leave y and x, you just need a and b. So all I have to do is figure out the b value. And we've noticed time and time again that the b value is always the hardest thing to find, figure out, work with. So obviously a little work is going to go in figuring this out. But here's what I would do. So you should look at this graph and on number 1 notice, oh, this is growth because it's going up. And on number 2, this is going down, so this one's decay. So I know on example 1, the b value should be bigger than 1. And the shortcut told us last time that to plot points to the right of the y-intercept, you just multiply by some number, and that number is your b value. So if you go over to 1, and again, I know this is hard to read, but the point's right there. This is 6, 7, at 8. So the y-intercept is at 4, and when I shift right 1, I'm landing at 8. So all you have to think is like, well, what do you multiply 4 by to get 8? You multiply by 2. So that is your rate here, that's your b value. Multiplied by 2 to shift over to the next point, so that's my b. So there's my function. Y equals 4 times 2 to the x. Over here, this is decay, so I know my b value should be a fraction. It should be less than 1. But again, all I have to think is like, well, what do I do to shift right 1? Well, when I shift right to 1 here, I land at 5. So if I start at 15 and I land at 5, well, what do you, and you can think multiply at first, but maybe think dividing before that. I know that to go from 15 to 5, I divide by 3. Okay, well, dividing by 3 is the same thing as multiplying by a third. So that's going to be your b value. Don't put 3 as your b value. You're not multiplying by 3 as you shift right. It would be growing if you did. You're dividing by 3. So same thing as multiplying by 1/3. Again, the b value, it's always the trickiest part. But if they asked you to write the function from a graph, that's kind of how you would think through it. The main focus of today, though, is being able to write a function if you're not given the graph, but given some points on the graph. So sure, I could plot the points, draw the curve, do what I just did, but there's maybe a quicker way to avoid doing that. And I don't know about you, but I don't want to plot the point 236. Like, no way am I counting to that. I'm not doing that. So here's what you would do if you were asked to write the function given some points like this. Now, I gave you 2 points. That's obvious. Think about which letters this represents and think about what the end goal is. It's the same as what it was above. So I'm trying to write a b to the x. I need a and b. Well, if I give you ordered pairs, that represents x's and y's. So you've got two x and y pairs. Okay, so that's good to think about. The y and the x here are being given to me right there and right there. What I can do is I can actually plug those values in for y and x, and I could do that for both of these ordered pairs here. And if I do that, I'm going to have a system. Yay, this is coming back to haunt us. We did systems at the end of last semester. So I can write two equations, which is a system of equations. The difference is this system is not linear. So if you remember, linear, those are lines. I know that these graphs are not lines. These are like curves. I don't know what the specific name, there probably is one, but these aren't linear. They're exponential. So that means I can't use like substitution and elimination. These are different, so I have to use a different way to solve these things to be able to write it. Here's what you would do. So I'm going to make a really important note off to the side here before I write my system. You need to remember that you're going to write two equations. The one you write first needs to be the one with the bigger x value. That needs to go on top. So make a note off to the side here. Always put the bigger x equation on top. Okay, so here's what I mean by that. Analyze the two ordered pairs first. Whichever ordered pair has a bigger x value, the first number. So that would be the second one here. The x value is 2, 1 is obviously smaller. I need to work with this information for my first equation. Okay, this is going to save you a headache in a minute, so analyze this before you go crazy and start. So basically, guys, all I'm doing is plugging in 36 for y and 2 for x, and I'm leaving a and b because I do not know a and b. So my first equation, it would be 36 equals a, b, and the exponent would be 2. For the second equation, use your other ordered pair. So this y value is 12, so it would be 12 equals ab to the 1. So all I did was plug in x and y, and I left a and b because that's what I'm trying to figure out. Those are the two things that I need. Here's how you solve this. So again, it's different from just like substitution and elimination. You're going to take the two equations, and I'm going to rewrite them just for the sake of you guys being able to read my work better. You're going to take these two equations, and you're going to divide them. Honestly, this is an Algebra 2 topic, so if you understand this and follow this, yay for you in 2 years from now. So I'm going to divide the two equations, and here's why I'm going to do that. So think about each part. The actual numbers, not the exponents, I can divide those. So 36 divided by 12, that's just 3. Bring down your equal sign. A divided by a, and here's where our exponent rules, this is why this applies here, the division exponent rules will come into play. Remember, when we're trying to bring a's together and you're dividing, you subtract the exponents. 1 minus 1 would be 0, or if you have like a over a, those just cancel out. That's exactly what you want to happen. You want one of the variables to go away, because then I'm going to be able to say what the other variable equals. So I've got half my answer. When you combine the b's here, subtract the exponents. 2 minus 1 is just 1, or just b. Okay, so by doing that, I have half of what I need. I have the b value. It's 3. All I got to do is find the a value, and I can write my function. So remember when you were doing substitution and elimination, when you found one variable, you always brought it back up and you plugged it into one of the equations to find the other variable. I will tell you, you can plug it into either one, but it's going to be easier to plug it in where the smaller numbers are. So don't go to where b squared is. Go to the second one where it's just b to the 1. So let's see, that's 12 equals, I don't know a, but I do know b now, so I'm going to plug in 3 for b right there. 3 to the 1's just 3, so to solve this for a, all I have to do is divide by 3. This is like very mathy here, people. Again, this is a lesson that you'll do in Algebra 2, so it's kind of a lot asking you guys to learn this, but we have faith in you. Once you have a, once you have b, you can put it all together to write your equation here. So it'd be y equals, always like go back to y and x. A is 4, b is 3. Boom. There's my function. Okay. Again, notice what cancels out when we did the division here. The a cancels out. Because of this, we can find the value of the other needed piece. We found b, so that's half the battle. Once you found that piece, we plugged it in to solve for the other. It's kind of a lengthy process. I think this is challenging for people because it is a lot of steps and you have to remember the process. But with practice, it's the same thing every time. So if you practice it a few times, you should get this down no problem. I want you guys to try number 1. Maybe watch me do a couple more examples first before you go back and try it. But I'm going to check this one next time I see you. Okay, let me do 2 more examples. I'm going to get my general form up here. That's my goal, being able to write this. I need a and b. All right, here's the process again. They give you x and y's for your exponential function here, and I gotta use this to find a and b. So remember this important note. You always take the ordered pair where x is bigger, and you use that information to write the equation on top. So let's see, I've got x is 1, x is 2. Obviously this one, x is bigger. So I'm going to use this x and y and plug it in and write that equation first. So the y value is 5, and the x value is 2. Then I'm going to come over here and use this information to write another equation. This y value is 20, and x value is 1. Okay, once you've written the 2 equations, you divide them. So this one, don't be freaked out. 5 divided by 20, you would just divide those 2 numbers, and it's 1/4. If you want to use a decimal, totally fine. I think a lot of you would prefer to write 0.25 instead of 1/4. A divided by a, those cancel. That's exactly what I want to happen. For the b's, you subtract the exponents. 2 minus 1 is just 1, so that's just b. Guys, the reason that I suggest to write the bigger x value on top, if you wrote it the other way, you'd be doing 1 minus 2, which would be a negative exponent. So you'd have to keep going, and it'd just be more work. So always write the bigger x on top so you don't have a negative exponent to deal with. Okay, so I have the b value, and again, if I kind of want to think about what the answer should look like, it should be like a times something to the x. I know the b value is 0.25 now. This would be decay. So all I have to do is find the a value. To do that, I take b and I plug it back in to one of these equations that I wrote. And I'm going to go to the one where the b value is just 1, so I don't have to square anything. So 20 equals, I don't know a, but I know b is 0.25. Something to the 1 power doesn't change, so I just am multiplying here. I have to divide by 0.25. So I would do 20 divided by 0.25, and that's 80 for my a value. Realize that you could have plugged it into the top equation where it was 5 equals ab squared. You would have gotten the same answer though, 80 for a. So now I can put that in and write my full answer. There's my function. All right, I'm going to do one more, and then you're going to try example 1 if you haven't already. But there's my x's and y's. I pick out the point where the x value is bigger. A lot of times that's the second one, but look closely. All right, I take that information and I write that equation first. So it'd be 27 equals ab to the 3. This one would be 3 equals ab to the 1. Then I divide the equations. 27 divided by 3 is 9. The a's cancel. 3 minus 1. Okay, this time it's b squared. Okay, you maybe know this, maybe you don't, but the opposite of squaring something is square rooting it. Or you can think to yourself, okay, well, what squared equals 9? Well, most of us would know 3 squared equals 9. So don't just think after you divide you're done, you have the b value. Sometimes you're going to run into like b squared. So you have to like think one step further. Square root of 9 is 3. So that's my b value. That makes this example just a little different. Okay, I'm going to come back up and I'm going to plug it into the second equation where b is 1. That's going to be a little bit easier to work with. I don't know a, but I know b is 3. So all I have to do is divide by 3. And I have a, which would just be 1. All right, put it all together. So y equals a times b to the x. All right, that concludes our exponent unit.